Good evening, everybody. Thank you for joining us at our latest webinar in the 22 series. We're really glad that you could join us this evening. We hope we're going to offer some interesting insights into some of the opinions that Dan has put out in our alert dive and various other publications, and we'll welcome your questions, which you can post during the actual presentation. My name is Francois Berman. I'm the Vice President of Safety Services here at Dan, and with me I have my team. Together we do our best to help the industry become safe and prevent accidents from happening. As I said, please post your questions. We will have somewhat of a delay, so if we don't get to your question immediately, we might do it between some of our topics we're going to introduce, or we'll get to it at the end. And if we still don't get to it, then please email it to us at riskmitigation@dan.org, and I'll bring up that email address again at the end of the presentation. So what I'd like to do first is to introduce my team, or our team, seeing we work as a team in safety services. First is Jim Gunderson. He's our Director of Training. And by training, we mean first aid training and all the other associated programs, really getting people prepared to respond to an incident. Then we have Christine. She's been with us since she was an intern. So clearly she found that she liked working with us and the work we were doing was good. And she looks after our risk mitigation. So where we find things in the industry that perhaps need to be changed through education, Christine will then address the mitigation. And then Wally Endres is the newest member of our team. He brings with him loads of experience. And his primary goal here with us is to help industry understand what the risks are. And then Christine steps in and she helps us to mitigate those. So I think it's a great team. We enjoy working together. And this evening we're going to be discussing with you where Dan comes up with these ideas about some of the topics that I'm sure you read about in the notes and in the advert before we did the presentation. So I'm going to start with Jim, and my question for Jim, the question that really came up in answer to a publication that we put out, is should cylinder valves be open fully, right back until the end, or should they be open to the end and then basically what we call a quarter turn back? And we put this out in a publication. We get all sorts of comments that come, questions that come. Some people are not happy with our point of view. So Jim, take us through how Dan got to that particular position.
Absolutely. This is a great topic. Thanks, Francois. So the question becomes, do we do it open or a quarter turn back? And the answer is, it's now fully open. And historically what happened was we started with a quarter turn back. And those of us that were trained a long time ago, and even some instructors now still teach a quarter turn back, but this is based in some history. This is based on some materials and some design. And the thought was, if they opened up the valve all the way, it would create a wear spot in parts of the valve internally. And that would then cause other problems down the line. The other thing was, people were opening it all the way and over-tightening it. In other words, jamming it open. So we obviously don't want to do that either. So they thought, let's turn it open all the way and then a quarter turn back. And this led to some problems. So more and more of the industry, and it started primarily with the technical side, has gone to fully opened. But also today, manufacturers of valves have helped do this, help mitigate this with some design and some materials. And this is a cutaway of a standard scuba cylinder valve. The air comes up through the dip tube, up through this little channel right here, and when the valve is closed, it stops right there. And then as you open it, the stem pulls back the valve seal and seat, and then the air, or the gas, travels through this channel into this little reservoir and then back up into the orifice where the regulators sit. And the engineers and the materials have improved so we don't get these wear spots. And so now the thought is we open it all the way up. We're still not jamming it open, but it's just a nice 2-3 finger turn of the valve until it is fully open. And the reason that we brought this about was there's been, now granted there's a small number of incidents, but there have been incidents where the diver had their valve partially closed, and this has led to some incidents, accidents, and in some cases fatalities. So when the valve is not fully opened, and as you drop, and it works fine on the surface, but as you drop down, that air, as we all know, gets more dense, and then has a harder time traveling through that channel when the orifice is slightly restricted. So we want to make sure the valve is fully open. There are those of us that were taught that way that have changed practices, and there's some that have been taught quarter turn back, and they still practice that today. But the recommendation is fully open.
Thank you, Jim. Yep. So I'm glad that he made some comments about engineers, saying I'm an engineer. And let me tell you, I'm an engineer, but I qualified as a diver many years ago in the 80s when we did have issues with the back seal or the back of the stem seal in the valve. And so my own practice these days is I always open the valve fully and then I just open it slightly that there's no pressure on the back seat. But let me put the question to you this way. If I'm on a dive boat and this is my practice, and the dive master or the dive supervisor or the boat, whoever's running the dive, says to me, no, you need to do the way I'm telling you to do it, how would you deal with that situation? Yeah,
that's a great question. And this happens from time to time. And when those situations come across, you want to make sure that you have a conversation with that dive leader that's on the boat, with your dive buddy, so you can discuss as a group why you're doing your practice the way you do it. Make sure that the dive leader is comfortable with that, and then do your dive. But understand that if the dive leader, because they're the boss on that boat, if they say it has to be a certain way and that's their hard and fast rule, understand that's their hard and fast rule.
If I don't accept that, then I don't
go
diving.
Then you have the option to not dive.
Yep. Fortunately, engineers understand some of this. So I think we're relatively safe with that. Okay, the next one we have, I'm going to ask Christine to answer this one. And the question that was asked was, should every cylinder that we essentially get for diving be analyzed every time, or only when we're actually using a gas mix, say nitrox or some other mixture in the gas?
Yeah, this really is a great question, and it's one that pertains to all diver safety when in the water. So the first thing that I'd like to mention here is that the only way that we can confidently confirm what is inside of a cylinder is to analyze it with a properly calibrated analyzer. And I say properly calibrated because this is important. If you do not trust the analyzer that you're using, be sure to grab a different analyzer to confirm the cylinder contents. Again, this is the only way that we can make sure we know what we are breathing on a dive. The second thing that I'd like to mention here is that human error does occur. So say I'm a diver, I take a cylinder to the fill station, and I ask for 21% oxygen. Well, the fill station operator may not have heard me correctly, or maybe was just having a little bit of a distracted day, and that person decided to put 32% in my cylinder. At the end of the day, it's still my responsibility to make sure that I know what is in my cylinder and what I will be breathing on that dive, so keep that in mind. Gas analysis is a risk management tool. Even though we know what's in the cylinder, we still have to be aware of our maximum operating depths, and also to just keep in mind what the training agencies say in terms of whether you're diving air or nitrox, and to stick to what you were trained to do. But Dan's stance on this whole issue is to analyze every cylinder every time. Even if you think 21% is in that cylinder, make sure you take a few moments, analyze it to confirm just that. And if you ask for nitrox, we still want to confirm that percentage because, again, human error does occur.
Thank you, Christine. So if I understand you correctly, either the dive operator should be presenting you with an analyzer that you can use to validate your own cylinder, or would you suggest then that the divers themselves avail themselves of their own analyzer, especially if they're traveling to areas that don't know that well, a shop that maybe does mixed gas or nitrox as well as air, where there could be some of these complications? What would you advocate, that the diver buys their own?
Well, I think there's two parts here. I think on behalf of the operator, I think it'd be a great idea for operators to start providing analyzers for their clients. Of course, they're going to get used a lot, so they will need to be maintained, but it's just an extra safety measure to let their customers know that they too, value gas analysis. In terms of divers buying their own individual analyzers, that's also a really good idea. And we understand it is an investment, but it's an investment in safety. And for that investment, what you are gaining is confidence in what you'll be breathing in the water. So I think it's a great idea. And if you're maybe diving with a buddy all the time, maybe you can invest in one together. But of course, you want to make sure that you're always analyzing that gas. So make sure you have an analyzer on hand one way or another.
Interesting that you make these points. Dan, people look to Dan for some guidance in terms of these events. And what actually happened to us here in this building is we teach gas analysis, show to scuba divers and operators how to actually analyze the gas. And we were provided with a cylinder, unmarked cylinder. It looks like a regular air cylinder. And obviously we were looking for carbon monoxide and all the other things that shouldn't have been there. But we noticed that the oxygen level was at 32%. So of course, my first thought was, perhaps there's something wrong with the analyzer. So I need to have an analyzer to check the analyzer, the calibration that you mentioned. So I called up the business that had actually supplied us with the cylinder, and I said, do you have any other cylinders in the same batch? Which they did. And I said, would you mind analyzing your gas, and then I will set our analyzer to the same value. Well, I didn't get an answer for a day. And the next day, a very sheepish person on the other side said to me that the whole batch of air cylinders that they'd ordered were at 32% nitrox. And you wouldn't know, the cylinder had no marking on it. There's no way that the diver would have known what was in the cylinder. So I know it sounds like we are going over the top. It's really up to the diver. The diver is the one that needs to take care of their own safety. And more than that, I don't think we can emphasize strongly enough the need to know what is in your cylinder. Remember, you can't see or smell or taste the gas. You're totally reliant on the people that have filled the cylinder.
Absolutely. I think the other thing to just briefly mention is you mentioned markings. So when you do analyze that cylinder, make sure you're putting your initials, the date, and the gas percentage to the first decimal point. I always recommend this to people because that proves that an analyzer has touched that cylinder. Anyone can write 32% on a cylinder, but if you see maybe 32.7, very specific, it's just a little trigger for your brain to let you know, hey, a cylinder has touched, or an analyzer has touched that cylinder.
Just remember, please, before you start, span your analyzer on 20.9% that there hasn't been some drift in the cell, and after that you'll have a pretty good indication of what is in your cylinder.
Absolutely.
Okay, they've left the technical one for me to answer. Just the way it works here, I guess, right, team? So the question here is goes around oxygen-enriched air, and what is the limit at which we should define oxygen-enriched air, meaning what is the limit at which we should start O2 cleaning our equipment, being the cylinder as well as the cylinder valve and obviously the first stage regulator. Now, when one looks into this, and this has been, I would say, a relatively contentious issue because the scuba industry has some pretty firm ideas about what is right and what isn't right. But if you go out into industry, you'll see a whole range of specifications, whether you're in Europe, whether you're in the States, whether you're in Australia, they all define this differently. And if you refer to the Code of Federal Regulations here in the US, you will see varying degrees of oxygen percentage again. But interestingly enough, in the section on commercial diving, lo and behold, there's this magic figure of 40%, which ties in very well with the maximum level of oxygen in a nitrox mix. And we've had some people tell us that this is in the law and therefore this is the maximum limit. However, you need to read what that article is all about. It focuses on commercial, it applies to commercial diving, low pressure oxygen application, so at breathing pressure, even though you might be at depth, it'll go down to just above the bottom pressure. And we are less concerned in the commercial diving setup because commercial divers know their lives are at stake and they keep everything clean. That doesn't apply to the higher pressure we have inside our scuba cylinders. So the scuba perception, as we sometimes like to use it, is 25, 32, 40, 100%. It really varies in between all of those. In fact, the US Navy even allow 50%, but again, they have specific controls that they put in place to make sure that they don't have accidents. Our concern, of course, is some or other volatile hydrocarbon that's got into the cylinder, maybe from the compressor, that then provides a source of fuel and a bit of heat, excess oxygen, an increased number of oxygen molecules, and that's how fires actually start. One of the confounding issues with fires in oxygen-enriched environments is that it doesn't always burn. You can try and replicate this as many times as you want to, and sometimes it will ignite at relatively low temperatures and pressures, and sometimes it doesn't. So what we like to do is to err on the side of caution, and how do we get to that point of knowing where that cutoff limit is? Firstly, let's emphasize the issue about high pressure. So if we have our cylinder empty, so it's at 1 atmosphere, 20.9%, we're not going to change the percentage, that's just a concentration. We'll have a certain number of oxygen molecules in that cylinder. As we increase the pressure to 200 times atmospheric pressure, over 3,000 psi, we now have 200 times more oxygen molecules available inside that cylinder. And I'll show you a graphic in a moment to illustrate how important this is. But the bottom line is that 21%, 20.9% air in a 200 atmosphere cylinder, 3,000 psi, has essentially 200 times more molecules of oxygen. That's actually where the problem sets in. So we are concerned in terms of O2 cleaning of our cylinder valve, and our regulator. After that, the pressure drops, and after that, even though in theory it's still oxygen-enriched air, we don't clean our demand valves, our second stages, and I'm not aware of any accidents we've had in that particular regard. So it comes down to what is an acceptable level of safety, what can we strive towards, and where does Dan come up with all these weird and wonderful figures from? Well, we go back to looking at research and seeing what has actually been tested and what history has shown in terms of actual events. So if we're looking at the figure you have over here, now please note this is at 1 atmosphere. So this is your cylinder that essentially has its valve off. And if you look at the increase in oxygen on the x-axis down here, you'll see it goes from 0 to 100. And if you look at the burning rate here on the left-hand side, your y-axis, as we increase the percentage of oxygen, you will see that about 40%, 45%, a massive increase, a very rapid increase in the burn rate over a small percentage range. And then it tends to kind of taper off. But of course, at this stage, you have a very, very fierce burning fire. This is at 1 atmosphere. So what happens now when we increase the pressure, say, inside the cylinder? This particular diagram is actually, it's not a theoretical diagram. They're what they call data plots. They physically carried out these tests. And at the bottom here, you'll see an increase in pressure. And please note, we're only going up to 10 atmospheres. In a diving cylinder, we'll have 200 atmospheres when we start our dive. And on this side, again, we have our burning rates. And the units sometimes change depending on what they're experimenting with. But take a look at our 21% normal air line. So if we take a burn rate of 1, okay, at 1 atmosphere, we're going to stick with 20.9% regular breathing air. And as we increase the pressure, look at the burn rate. And it'll continue. If you went up to 200 atmospheres, it will be somewhere up over there, really an uncontrolled fire. If we then decide to increase the amount of oxygen, there's 25%, relatively similar to 21%. But look at the 40% line over here. You can imagine if you had 40% mix with oxygen inside a cylinder, you take that up to 200 atmospheres, all bets are off in terms of what sort of ignition you can get out of that. So that's the science and the research. And what we try to do at Dan is look at the research, look at the science. You'd expect that from us. And then blend in with that a degree of practicality. But here's really the rub. We've seen with organizations like CGA, their recommendation is 23.5%. And our retort to that is, well, why would you have 23.5% in the cylinder? You wouldn't set out to put 23.5%. You'd set out for a minimum of 25, which is where nitrox starts, and then obviously work your way right up to 40% or more, depending on your plan and your dive plan. 25% would then be your target. Okay, so you wouldn't expect to get less than that. You wouldn't be analyzing for less than that. But the science has also shown that at 25%, that burn rate starts to increase exponentially. So we have a practical part of this, and we have science to back it up. And our point of view, our recommendation, we don't make the rules, we just make recommendations. And it's validated by the organizations like the American Society for Testing of Materials, where they physically lit fires and measured what the burn rates are, that anything above 25% is oxygen enriched, and that means that the cylinder valve, and the regulator need to be cleaned for oxygen applications. So what did we get out of that, Wally?
So Francois, I've heard some divers say, well, I'm not partial pressure blending my tanks. I'm diving with nitrox, but I'm not putting pure O2 in my tank, but I'm going to run a 32% mix, a pre-mix or banked air. Does that still fall under that same consideration of cleaning that tank, O2 cleaning that tank?
So it's a misnomer whether you're going to be partial pressure blending means you're starting with 100%. We have all the fear on the 100% side, but what we've lost sight of is we're still adding oxygen molecules inside the cylinder. And as you increase the pressure, the number of molecules is going to increase. And if we have any oil in there, it was an air cylinder, we were running it through a regular compressor. The US limit on oil is 5 milligrams per cubic meter. It's a factor of 10 higher than they allow in Europe. So it is theoretically possible, not if the compressor is properly maintained, but to have oil in the cylinder, and you meet that spec. And now you add extra oxygen into that cylinder, and that's where the concern comes. So whether you're doing real time through a membrane or partial pressure blending, it doesn't really matter. We are concerned about the number of molecules of oxygen that are going to sustain the combustion. So it doesn't matter whether it comes from a bank of premix whether you partial pressure blend it or whether you make it in real time using a nitrox generator. Something to think about, and I know some people have been fairly upset with the guidelines we put out there, but we think about what we're doing, we discuss it, we look at history. I think we do a pretty good job, and I'm confident to stick at that level. That's enough from my side, right? All the theoretical stuff. So Wally, please take us through the difference between an SMB and a DSMB.
Well, I have this discussion quite often with my students. They come to me after training and they say, hey, what's the difference between the SMB and the D? The SMB obviously is surface marker buoy, and the DSMB a delayed surface marker buoy. The difference is in the mechanics of the buoy, of the tool itself, where the SMB is sealed all the way around, and what it doesn't have is the overpressurization valve, as seen in the diagram here. The overpressurization valve allows the diver to deploy the Dsmb from depth, and as it ascends to the surface, to alert people for surface support that there is a diver down below. If the diver happens to put a little too much air, Boyle's law takes over. The overpressurization valve will allow a little bit of that air to come out of it, so it doesn't actually do physical damage to the self.
Awesome. Well, thank you so much, Wally. I think, as you mentioned, we get questions like this all the time. And just from personal experience, I think I'd like to harp on three main things that, regardless of if we use an SMB or a DSMB, these three main ideas apply. The first of which is to never clip one of these devices to yourself once they're deployed, unless you two want to end up on the surface with that SMB or that DSMB. The second one is to always properly manage line, because as we know, line can be very, very deadly, so we want to keep that under control. And the last but not least is proper training is key. So regardless of which one you choose to use, you want to practice often and get those skills up. But my question to you is, what about color? I've seen a bunch of different colors out there. Some DSMBs have some interesting features. Can you elaborate on that?
Yeah, so I think in most cases, color may be a marketing tool for the manufacturer, but divers tend to use these devices in different manners. There's a means of putting a chem light or some sort of lighted device on them. There's a hook on the top on some of them that allow divers to add a note. Some divers will carry two DSMBs with them. Maybe one's orange, maybe one's yellow. They use the orange one to alert surface support that maybe they're just on a safety stop or doing a decompression stop, and that everything is okay, and they want that surface support boat and people on board to know that things are calm and good. Perhaps they launch the first one to say that they're on their deco stop, and then the second one gets popped up a few minutes later. Maybe it has a note, or maybe it was just a predetermined conversation with their surface support that second one pops up that's a different color and actually warns the surface support that there's a problem down below. That's usually a conversation that happens on the boat beforehand, so people understand what their process is for alerting surface support if they really need help. One of the things I really want to point out is that no matter what you have for a surface marker buoy, we really kind of advocate that you get the Dsmb with that overpressurization valve, because it has far more uses in the long run than just the surface marker buoy that kind of sits at the top and doesn't really get utilized as a tool from down below.
Anything else?
I think that's it. I think that covers it very well. Thanks so much, Wally.
Thanks, Wally. I've been watching some of the questions coming in, and let me start. The first one's not a question, it's actually a statement. And the statement relates to the quarter turn open, that this is my kit and no one messes with my kit, which, fair enough. I mean, some of us might have the same opinion. But remember, that dive operator, that pro, whoever's leading the dive, is the one that has legal liability for the safety of the person in the water. So yes, it's your kit. You can make that decision. Then you probably need to decide to dive somewhere else. Or maybe you need to talk to the shop before you go diving to explain your position and no one touches my kit. We completely get that. But put yourself in the shoes of the dive leader that then carries the legal liability that they will be exposed to if something actually goes wrong. But it's an interesting question. I'm not going to advocate for or against. I would have that discussion before I went diving
Absolutely.
rather than when I'm about to get in the water. There's a great comment down there about is 22% not actually enriched air? And in one of the European documents, they actually say that anything above 20.9% is enriched, and it's true because to get above 20.9, you need to add oxygen. So you're actually enriching oxygen. Second point is, remember from the curve on 21% how rapidly it burns? 21% at 200 atmospheres has so many more oxygen molecules that it actually reacts as if it was a low percentage at a lower pressure. You get the same reaction at 200 atmospheres. So that's a pretty good point that they made. And then somebody was questioning us on 25% nitrox. Yes, in the old days, 25% was a figure that was used. We don't see it that much anymore. 28, 32, occasionally 40% of the normal parts of that. Jim?
Most of the training agencies actually define nitrox from 25 to 40%, and that's where that 25 comes in. They're saying anything above 25. Now we're talking the oxygen cleaning, which backs up our position as well.
The other thing I was just thinking, as you said that, Jim, was today you're diving 25%, tomorrow you're diving 40%. And so you need to prepare your cylinder for whatever eventuality you're going to have. So it might mark that it's a nitrox cylinder. But if you decide that 32% is the limit, then you can actually not add 40% to it. So a great question. So please get those questions coming along. And I do see another comment over there for recreational purposes. Folks, when it comes to commercial divers, they clean everything. They don't take chances with anything. So don't equate scuba divers to commercial divers. It's kind of like chalk and cheese.
Or even when we're talking technical diving, when they're using percentages greater than 40% as deco gases. We're talking, and obviously those have to be totally oxygen clean.
There's no difference between totally and oxygen cleaned.
But we're talking about for the standard recreational diver who has a nitrox certification from that 25 to 40. That's where this point is. The technical divers, they've got the additional training. Of course, they know that those cylinders need to be oxygen clean 100% of them.
Put yourself in the position of the dive shop too. They get a cylinder, it's not marked what percentage it was clean for, and they're going to put in. So essentially, any time you're going to add oxygen for whatever reason, we regard it as being oxygen enriched, and 25% is the first minimum level that they would actually enrich it to. So for our last question, Jim, I think you're probably the best one to answer this particular one. Can you explain to us the difference between a certified diver and a qualified diver?
That's always a great question. So am I certified, but am I qualified? And the reason I'm asking this is when we take a given course and we go through all the skills that have been outlined by that training agency, and we've worked with that instructor, and we've demonstrated those skills in a proficient enough manner to be certified. Okay, I've completed that given course, and that instructor gives me a certification card, and that's all fine, well, and good. It's fantastic, excellent, love it all day long. But are you qualified? But the standard says that you're qualified to dive in conditions similar to that in which you were trained. Okay, so if I was trained in the beautiful, warm, crystal clear waters of the Bahamas, or down somewhere in the Caribbean, maybe Cozumel, St. Thomas, something like that, I'm trained in those conditions. But as we all know, conditions can vary. And let's take a couple of these. You're on a boat versus a shore dive, or you're diving, your site is colder versus warmer water, or clear visibility versus limited visibility, currents versus no currents. So if I was trained in those crystal clear, calm, beautiful, warm waters, and I go to, say, the upper New England states or the Pacific Northwest, where that visibility is significantly less, sometimes 10 feet or less on a regular basis, and it's cold, where 7mm wetsuits and dry suits are highly recommended, and you've got currents because of the tide exchanges going on. So these are conditions that you may not have been trained in. So yes, you have that certification, but are you qualified to dive in those conditions? So really, to become qualified is a combination of your training and your experience. Yeah, so when you go to those new locations, those new dive sites that you've never been to, and you're diving those conditions that you don't have that training in or that experience in, you need to get with those, and you need to get with a dive shop, you need to get with an instructor and get some training and get that experience in order to do that dive in a safe manner.
Awesome. Well, thank you so much, Jim. And, this conversation actually brings up a point that I heard recently about gaining that experience. And you kind of just touched on it there, but I want to use an example that I saw in real life. And it was a dive operator that ran a boat charter. And one of their prerequisites was to have a certain number of boat dives. So how does one without any boat experience gain boat experience to go on that excursion? What are some tips and tricks that newer divers can use to gain that experience?
That's a great point. And sometimes it's also a catch-22. You need the experience to get on the boat, but you need that experience to get on the boat, but you can't get on the boat because you don't have the experience. So what do you do? How do you do this? So there are some operators that have those conditions, and that's okay. That is their prerogative. They've analyzed that risk, and that's the criteria they put in place to minimize that, to mitigate and minimize their risk. So you as a diver can go to a different operator to gain that experience. That's one option. Or you do a boat dive on a lake where it's much more calm. So you can actually gain some of that basic knowledge, and then you can transfer that. Now we're going to go to the ocean. We're going to do that dive with that particular operator because they're going to a site that we really want to go to. They're going to go to that wreck or that reef structure that we want to see. But we know it's in more rough conditions. So they want to make sure you have that experience. So that's one way of doing it, is get with different operators. The other option is to get with an instructor and get on the boat, get with that instructor. Take that specialty course. If you need to learn how to dive limited visibility or at night, take that specialty course. And that's another great way. Again, it's a combination of training and experience. You get the training with an instructor, and you get that training by and you get the experience by doing the dive.
Absolutely, and I think this brings up one last point that I'd like to make here, and this is about mentorship and the importance of mentorship in our industry. And I think there's something here for both the diver and the dive professional, or those that are more experienced. So for the new diver, go out and find a mentor. Find someone who has more experience than you, and gain as much knowledge as you possibly can. Repurpose that knowledge and make yourself a better diver. And for those experienced individuals, do yourself a favor, go ahead and find a newer diver to mentor. It is one of the most rewarding experiences that you can have, and this is how we as an industry grow. So I think mentorship is key here, especially in the certified versus qualified debate.
Absolutely. And even when you've got two relatively experienced divers, they're going to have different experiences in different conditions, and they can help mentor each other, even as peers. I mean, I've learned a lot from my other fellow instructors, and I know they've learned some stuff from me. And been diving for over 30 years now, and so there's an opportunity there. And speaking as a dive professional, I love taking newer divers under my wing. I absolutely love it. I don't expect to get paid for some of that, but it's fun to watch them grow. So yes, so avail yourself of those mentorship opportunities and make yourself available to be a mentor.
Never too old to learn something new.
Absolutely.
So I've been watching some of the questions come in here, just two that kind of spring to mind immediately. The first is we have somebody that is hearing impaired and asking if there are closed captions available. I did think that YouTube gave you that option to play closed captions. I'm not sure, but that's something we can certainly look into. So once the video has been posted online, we can see whether closed captions are an option. That's a great comment. Thank you for that. Then I saw one there that was kind of like a controversial question. What sheet are we reading these questions from? So let me put it to you this way. We write some articles and we put out some opinions, some postings in Facebook and so on. And we get kickback, people that don't agree with Dan's position on something. So we've taken real questions. These aren't questions we made up. We just kind of sifted through. We often get asked the question that somebody saw some bad practice out in the field, and this is not that uncommon, and Dan should take action. Clearly, Dan can't take action. What we can do is try to educate, get to the bottom of it, talk maybe with a dive operator, and just really see what we can do to improve the situation, make the situation safer. But we're not the police. We don't write rules. We provide guidance, education, and hopefully through that way, people will actually start better practices. So that's really where we get this you might call it a hymn sheet. We didn't have a hymn sheet. We just selected some of the controversial topics, knowing they'd be controversial, and some of you already posted some questions. And that's really why why we put on this event this evening, is because it's not always cut and dry. Your point about certified and qualified, and I'm sure many people think that once they're certified, they're qualified to do anything. And sadly, that's when things go wrong.
Correct.
So I didn't see any other new questions, unless my eyes are not what they used to be.
I
Christine?
do see one there at the bottom. Opinions on integrated weights or a weight belt. So basically weight systems. And what's kind of funny is we actually had this discussion in the office yesterday. So I think one of my peers to the left or the right are probably best first to answer this one. Whoever wants to tackle that.
Flip a coin.
Flip a coin. I guess the way I was trained as an instructor, most BCs, modern BCs now have integrated weight systems. So the weight belts are kind of, I guess, use the term old school a little bit loosely, but as you get into some more elevated training and areas of potentially technical stuff, some divers tend to opt for those weight belts. It's just another piece of equipment that can be easily modified, or not modified, adjusted, adding weights and removing weights, as compared to the weight systems that have the quick release units on them, plastic that can degrade over time, buckles that can break. A weight belt and the old trusty lead weights are a pretty good way to go. They probably won't fail you. Where some of these new systems and can get stepped on or dropped and broken, and there's a higher risk of some failure points.
I think that at the end of the day, it comes down to comfort, personal choice, and knowing your equipment. So if you have an issue, that you know how to bail out.
Exactly.
So most of us, I think, would dive with what we feel comfortable with.
Yeah. Whether it's integrated or weight belt or a weight and trim system or different type of system, it's what you were trained on, what your buddy's aware of. So when you're doing your buddy checks, make sure that's one point that you emphasize, is how do I get you out of your weights and how you get me out of mine? Is it a pull on each side? Is it a standard weight belt with the right hand release? Is it a single toggle with a monofilament line? So have that discussion. There's pluses and minuses with each type of weight system, but again, fall back to your training and your dive checks with your buddy.
And I think at the end of the day, Jim, one of the other important considerations here is, regardless of what weight system you choose, proper weighting is key.
Oh, absolutely.
Yeah, at the end of the day, that's really what we want to harp on, but you said it perfectly. And I do have one for you, Jim. I see it in the questions here, and it's in regard to your certified versus qualified. And does this extend to instructors as well?
Oh, absolutely. Absolutely. Going back to when someone becomes an instructor, again, they've demonstrated to that particular course director or instructor certifier, depending on which agency you're going through, that they've checked the boxes to become an instructor. And when they start teaching those courses that are more outside their comfort zone, they as the instructor should have the discipline to go back and get the education, get the experience, and get the knowledge before they start teaching that. For instance, I'm certified to teach spearfishing. My spearfishing consists of one dive where I harvested exactly 0 fish. I am not qualified in any way, shape, or form to teach anybody spearfishing. I know that. And if I were, I would want to go out and do dozens and dozens and dozens of dives, practicing those skills before I even begin to operate. So.
That was an interesting point you make, because when I was doing my open water training all those years ago, I watched my instructor, and he decided one day to take us to a new area where he hadn't actually been diving before. And before he had actually told us about it, before he would take us there, he went to a buddy that was competent to dive there and went through all of the steps so that if we got into trouble, lost visibility, if there was a current surge, he'd know how to deal with it. So that's really what you expect from an instructor, isn't
Absolutely.
it?
And I would like to put a shameless plug out there. Quarter 3 of Alert Diver will actually have an article geared directly toward this conversation in what qualifies an instructor to teach a rescue course. So watch out for that one. And you know, with your questions and comments that I'm sure will loom, send them our way, and we're happy to answer them.
Thank you, guys. I think that was really very useful, and hopefully people will come along with their controversial questions. You can email them to us. We have an email address that Christine will put on the screen for us in a moment.
Actually, Kyle's already got that taken care of because he's 3 steps ahead of us. Kyle's behind the camera and doing a great job tonight. And I think Jim sees the same question that I see. So,
Well, I see 2 there, and I want to point out the first one, and that's a comment by Steve. He says, closed captioning is running on the Dan Facebook page. So thank you, Steve, for taking care of that and letting us know. So that's fantastic. And then I assume you're talking the 10% weighting?
absolutely, go for it.
Okay. So talk about overweighting. Should the old 10% still be used? No. The short answer is no. You want to be properly weighted. There are conditions where, yes, you do want to be overweighted. If you're diving in a higher current, yes, you might want to overweight some. But on a dive by dive by dive basis, you want the proper weighting. You know, if you use 12 pounds, you're not going to add a pound and a half, 2 pounds. Stay at that 12 pounds. So properly weighting.
Awesome. And I don't want to throw Wally under the bus here, but I know we were talking about this before this webinar tonight, overweighting with open water students. Any interest in touching on that? I think it's a really important point to bring up.
I have a problem with that mentality. I try to train my students that there is a right and wrong way of weighting yourself, and it's a process that doesn't happen immediately. It takes some time and adapting to your gear. You may change your gear. You may change different weights, wetsuits, and exposure suits, so that adjusting your weight system also aids in your trim and your buoyancy. So it's dialing in that appropriate weight setup. And really maintaining a good log of how you're changing that lead. Overweighting, obviously underweighting is going to give you major problems and buoyancy problems. You can bring it back to the surface, but overweighting is going to be a whole wealth of potential problems. Yeah.
That.
Stephen Crosby has asked another question. Does Dan have detailed information about dive accidents that happen when a diver combines specialties versus a single specialty, aka a night dive that's also deep? So there might be some detailed information. For those statistics, that's a better question for our research department, research@dan.org. But what I will say is, if you're working on those types of combinations, let's use that term, combinations, and you don't want to be doing a night dive and a deep dive for your first time at the same time. You want to do a series of night dives or a series of deep dives, so you've got those skills and you're comfortable with those skills before you add another challenge, another skill set. So work on one variable at a time. Don't do 2 at a time.
Absolutely. And I do see the question that I pretty much expected from tonight, which is the age-old split fin versus solid fin debate. I'll go ahead and take this one, and I think I'm going to stand by my approach of there is an application for both. I am a huge solid fin fan, but there are applications for both, and both need to be acknowledged while he's over here.
This is a great one, and actually, I learned the appropriate way to remove a lionfish from your spear is by putting that spear tip with the lionfish in between your split fin and yanking that thing out and letting it die. So purpose-built split fins, yeah.
But there is an application for both, and I think there is a place for both styles in our industry.
Absolutely.
And I think just personally, the stigma behind split fins needs to go away for the betterment of the community, because at the end of the day, the diver is going to choose what tool is best for them, and others need to be accepting of that as well.
Absolutely. I mean, I own solid fins, I own split fins, and I love them both for the right applications.
Absolutely.
So.
Well, I think we should let our folks enjoy the rest of the evening. So thank you for tuning in and listening to us. We'd like to give a special mention to our Dan members. Without them, we couldn't host events like this. Without them, we couldn't be working on these preventive safety programs and first aid programs and everything else. So thank you for your support. You should know that it is always greatly appreciated by us here at Dan. And for those of you that might miss this or need to watch it at a later stage or pass it on to somebody else that might be interested, it will be on our dan.org website as well as on our Dan YouTube channel. So you're welcome to watch it at any time at any later stage. So once again, thank you very much for being here and enjoy the rest of your evening, night, daytime, wherever you are around the world. Thank you.